All right, everyone, get ready for today's deep dive because we're heading into the world of large language models, those AI systems that can write poems and answer questions, even generate code. And we're going to try to answer a question that's been making waves recently. Can these LLMs actually think like, well, statisticians? Specifically, can they learn and change their predictions based on new evidence, just like we do with something called Bayesian reasoning?
It's funny you should bring that up because you actually sent me this research paper called Enough Coin Flips Can Make LLMs Act Bayesian. And it's really interesting. The researchers put these LLMs to the test using the classic example of biased coin flips.
Oh, okay. So for anyone who needs a little refresher, Bayesian reasoning is all about updating what we think as we get more information. It's kind of like, well, imagine a jar full of cookies. Some of them are chocolate chip and some are peanut butter. You reach in and grab one at random. Maybe you have a guess about which one you've got. But then you take a look and you see chocolate chips. Now, you're pretty sure it's a chocolate chip cookie, right? You've just updated your belief based on that new evidence you got.
Yeah,
And that's Bayesian reasoning in action.
exactly. And in this paper, the researchers wanted to see if those LLMs could do something similar, but with coin flips. Could they figure out whether a coin was fair or biased just by looking at a bunch of coin flips? And if they could, would they adjust their predictions in a way that actually makes sense, statistically?
So they're basically trying to teach these LLMs to be like coin flip detectives.
Pretty much. But here's where it gets really interesting. They found out that a lot of these LLMs, even some of the really advanced ones, had this weird tendency to predict heads even when the coin was supposed to be perfectly fair.
Wait, really? Why would they have a bias towards heads? That seems so random.
I know, right? It seems counterintuitive. But it actually highlights a key insight about these LLMs. They can actually pick up these unexpected biases from the data they learn from. Even from something as simple as how words are broken down into those small units of text, the tokens they process. So sometimes the way tails gets tokenized can actually influence the model's prediction a little differently compared to heads.
So it's not like they actually prefer heads or anything. It's more like a quirk that comes from how they learn language.
Exactly. And to make things even trickier, the researchers tried to fix this by explicitly telling the LLMs things like, this coin only lands on heads 25% of the time. But surprise, surprise, that didn't always work.
Oh, wow. So even when they were given the facts straight up, they couldn't shake that heads bias. Some of these LLMs sound like my friend who's convinced his lucky coin always lands on heads.
Well, it actually depended on the specific type of LLM they were testing. The ones that hadn't been specifically trained to follow instructions, those non-instruction tuned models, basically ignored that extra information and stuck with their initial bias. It's like they were so set in their ways, they just couldn't be swayed.
Okay, yeah, that makes sense. But what about the LLMs that were trained to follow instructions? Did those do any better?
Yeah, so the instruction-tuned models did show some improvement, especially when they were dealing with those extreme cases, like a coin that always landed on heads or always on tails. But in general, just giving them those explicit instructions wasn't enough to completely eliminate the bias. It seems like these LLMs are a little more complex than just, simple rule followers.
So if just telling them the truth wasn't enough, how did they finally get these LLMs to think straight about these coin flips? What was the key to kind of unlocking their inner statistician?
Well, that's where the power of what we call in-context learning, or ICL, comes in. So instead of just saying the probability, the researchers decided to show the LLMs a bunch of actual biased coin flip results. So for example, they'd show them a sequence like heads, tails, tails, tails to illustrate that the coin was biased towards tails.
Ah, so they were basically letting the LLMs learn by example instead of just lecturing them about probabilities. Kind of like how you might learn a new skill by watching someone else do it.
Precisely. And what they found was really interesting. When they gave the LLMs those in-context examples, they actually started updating their predictions to match the actual bias in the examples. They were actually learning from the data. It's a really cool example of how in-context learning can actually help LLMs adapt and improve.
Okay, so that's starting to make a lot more sense. But I'm curious, did the size of the LLM make a difference? We always hear that bigger is better when it comes to these models. So were the larger LLMs better at learning from these examples?
Well, that's where things get even more interesting. The size of the model didn't actually guarantee better in-context learning. In some cases, the smaller LLMs were just as good, sometimes even better, at picking up on those patterns from the coin flips.
Really? That's surprising. I always thought those bigger models were just inherently better learners. Does this maybe suggest that there's a difference in how they process information? A qualitative difference rather
Yeah.
than just being bigger?
Yeah, it definitely challenges some of those assumptions we have about what makes an LLM really effective. It seems like it might not just be about how big they are, but how they're trained and how they process that information in context. It's a good reminder that we still have a lot to learn about how these models actually think.
So are we saying then that these LLMs are basically becoming like little Bayesian masterminds, perfectly following all the rules of probability?
Well, not quite. While they did show those Bayesian-like updates, their behavior didn't perfectly match a pure Bayesian process. Remember how we talked about updating your belief about those cookies in the jar? A true Bayesian updater would consider all the cookies they've ever picked from that jar, all that historical data.
Right. They'd be thinking about the entire history of their cookie selections.
Exactly. But in this coin flip experiment, it looked like the LLMs were focusing more on the recent examples. It's kind of like they were saying, hey, I just saw 5 tails in a row, so this coin must be biased. They might be using what we call a time decay factor, where those older examples have less and less influence on their current predictions.
Oh, so they're kind of more short-sighted in their learning, more influenced by what they've just seen recently? That's pretty interesting. It's kind of like how we might react to a sudden change in our environment, paying more attention to the most recent information.
Exactly. And what's really cool is that the researchers actually calculated a discount factor for different LLMs to quantify how much they are prioritizing that recent information. And guess what? Those instruction tune models actually tended to have a higher discount factor, which means they were even more short-sighted than those non-instruction tune models.
That's fascinating. It seems like training them to follow instructions might actually make them more sensitive to the newest information, even if it means they kind of forget that older stuff faster. It's like they're hyper-focused on what they've just been told.
Now, there's one final piece of this puzzle that's worth exploring: the role of attention. You know how those LLMs zero in on certain parts of the input they receive? It's like they're focusing their attention.
Yeah, I get it. It's kind of like how when we're reading a book, right, we might pay more attention to some sentences or paragraphs than others. Depends on what we're trying to understand, I guess. We're always kind of shifting our focus as we read.
Yeah. Exactly. So the researchers thought, hey, let's look at how much attention these LLMs are giving to the specific parts of the coin flip sequences that show us the bias. They figured maybe that would give us a clue as to how well they were learning.
Oh, so like if an LLM was really paying attention to those tails-heavy sequences, that would mean it was really picking up on the pattern, like it was zeroing in on the evidence.
You'd think so, right? But here's the interesting part. The amount of attention they paid wasn't a surefire indicator of how well they learned that bias. It wasn't just a case of, oh, more attention equals better learning.
Wow. Okay, that's kind of a curveball. So if it wasn't just about paying more attention than what was going on, how were they figuring out the bias if it wasn't through that focused attention?
It's a really good question. And to be honest, it suggests that there's something else going on under the hood, something a bit more nuanced that we haven't quite figured out yet. One theory is that it's not just about how much attention they're paying, but how that attention changes over time.
Oh, so maybe it's like the difference between like quickly glancing at a page versus really sitting down and studying it, taking in every detail.
Exactly. Even if the overall attention score doesn't change that much, the way that attention shifts and focuses over time might actually be a huge part of how the LLMs are learning and adapting.
Okay, that's really interesting. It paints a much more complex picture of how these LLMs work than I think we initially imagined. But let's zoom out for a second and think about the bigger picture here. What does this all tell us about the ability of these LLMs to make good predictions, especially in more complex scenarios, real-world situations where the rules aren't as clear-cut as a simple coin flip?
That's the million-dollar question, isn't it? And it's something researchers are working hard to understand. On the one hand, it is really encouraging to see that LLMs can show us this kind of Bayesian-like reasoning, especially when we use in-context learning.
Yeah, it's like they're not just spitting out information. It seems like they're actually capable of learning and changing based on new evidence.
Right. It points to a deeper level of processing than we might have initially given them credit for. But, and there's always a but, we can't forget that these LLMs are trained on massive amounts of data. And all of that data, well, it reflects all of those human tendencies and quirks.
Including those biases, right? Like we were talking about with the whole heads bias.
Yeah.
It's almost like they picked up on some of our subconscious preferences through all of that data.
Exactly. And we have to be aware that those inherent biases might be influencing their predictions, sometimes in ways we don't even realize. It's a good reminder that we can't just assume that LLMs are perfectly neutral and objective.
So we got to be careful, right? It's like we're exploring a new frontier, and there are bound to be some unexpected surprises along the way.
I totally agree. And this is where all of this ongoing research is so important. We need to figure out how to minimize those biases. Maybe it's through better training methods or choosing the data sets more carefully, or maybe even developing new techniques to explicitly remove those biases from the models.
So it's almost like we have to teach these LLMs to be good statisticians themselves,
Yeah.
like help them to recognize those potential biases and learn to approach problems with a more critical eye.
I like that. It's like we need to give them the tools to handle uncertainty and complexity, to make decisions that are not just accurate, but fair and equitable too.
And that becomes even more important, I think, as we start using LLMs in more and more areas of our lives, from healthcare to finance, education, and beyond. We need to be sure we're using these powerful tools responsibly and ethically.
I couldn't agree more. And that's actually where things get even more interesting, because we're not just talking about individual applications. We're also using LLMs to build virtual worlds, to simulate how humans behave and interact.
Mhm.
Just think about what it means if those simulations are based on biased models.
Oh, okay, yeah. That's a huge thought. We're basically creating virtual societies that could inherit and even amplify those biases from the LLMs that power them.
Exactly. And it brings up so many questions. How do we design and govern those virtual spaces? How do we make sure they're inclusive and representative? How do we prevent them from making those harmful stereotypes even worse or increasing inequality?
Wow. It's a lot to think about. It really emphasizes that we need to look at this from all angles. It's not just about the technology itself, it's about the values and ethics that we build into it.
Absolutely. It requires everyone working together, the computer scientists, ethicists, social scientists, and policymakers to shape the future of these tools, to make sure that LLMs are developed and used in a way that benefits all of us.
It's like we're on this journey of exploration and discovery, isn't it? We're not just diving deep into how these LLMs work, but also into our own responsibilities as we figure out how to navigate this new territory.
You said it. And as we wrap up this part of our deep dive into this whole world of LLMs and Bayesian reasoning, I think it's time to leave our listeners with one final thought-provoking question. So we've been talking about how those LLMs can learn and adapt their predictions, even showing some pretty impressive Bayesian-like reasoning.
Yeah, and how those abilities make them, well, potentially really useful for all sorts of things.
Yeah.
From helping us write to, like, speeding up scientific discoveries.
Right, but we've also been talking about how they can pick up biases from the data they learn from, which brings up some really important questions about how we use them.
Especially as we're using them more and more to simulate human behavior and build those virtual worlds we're talking about.
Which leads us to that thought-provoking question I mentioned earlier.
Let's lay it on us.
So if we're using these LLMs to model and predict how humans behave, could those biases actually end up distorting those simulations they're creating?
Ooh, yeah, okay. That's a big one. It's like it's like we're creating this funhouse mirror of humanity where those reflections are all warped by the biases that are kind of baked into the algorithms.
Think about it. Imagine a world where we're using LLMs to model everything. What people buy, their political views, social trends, you name it.
Yeah, and if those models have those hidden biases, the results could be really misleading. Right?
Exactly. We might think we're getting this accurate picture of reality, but it could be skewed in all these subtle ways that we don't even recognize.
It's like we're using a map that's, a little bit distorted. We might think we're heading in the right direction, but end up way off course.
Precisely. And that's why it's so important to be critical thinkers. We can't just take the output of those simulations at face value, We have to ask ourselves, what are the assumptions behind them? What are some other ways of looking at things?
So it's not just about making these LLMs super smart and technically advanced. It's about using them responsibly and ethically.
I think that's a great point. It's about remembering that these are really powerful tools and they can really shape how we see the world, even how we see ourselves.
It's like we have to be really careful and always question the information we see, especially as those LLMs become more and more a part of our everyday lives.
I agree. We need to be curious, think critically, and be open to having those tough conversations.
Well, on that note, I think it's time to wrap up this deep dive into LLMs and Bayesian reasoning.
I hope you enjoyed exploring these ideas with us today. It's definitely a lot to think about.
And we hope you'll keep pondering those questions we've raised.
Because as those technologies keep evolving, it's really up to all of us to make sure they're used to create a better future for everyone.
Thanks for joining us, everyone, and we'll catch you on the next Deep Dive.